All right, my name is Huyen Tue Dao, and I'm an Android developer. I work at Trello. I've been doing Android for about 6 years now, and I'm here with you, very happy to be here with you to talk about loving lean layouts. Now, what on earth do I mean by that? Layouts are actually one of my favorite parts of doing Android development. You know, this idea that you have this XML file, right? And XML is like not new and sexy. It's old. It's been around for a while. It's kind of simple, but these XML layouts form the foundation to these beautiful and expressive and engaging applications we make as Android developers, right? So the thing is that because they're I feel like they're really straightforward, they're easy to get started with, but I think because of that ease, a lot of times we kind of exclude layouts from discussions like performance. And basically, like the gist of my talk today is to let you know that layouts do matter in terms of performance. And I'm going to tell you why. And basically, I'm going to tell you why you care about this talk at all. What's a lean layout and why do you care about it? And how does performance play a role in developing layouts? And what problems can occur? And I'm going to tell you how to find these problems. And once we find these problems, we're going to talk about how to fix them. And at the end, I'm going to talk about some good practices when you're doing layouts. I generally don't like to say best practices because I feel like what's best for you depends on you, your team, your application, how the stars are aligned in the sky. So I'm just going to give you a few of my kind of personal tips and tricks and kind of guidelines for doing lean layouts. So why lean layouts? Well, lean layouts matter because, as you might have heard, perf matters. And, you know, we talk about performance. What is performance? Well, we talk about an application being, or we measure the performance of an application in how many resources it consumes. Now, usually we think about resources as memory or as CPU time. Now, when it comes to your layouts, the amount of resources that layout takes up is directly proportional to its complexity. So what makes a layout complex? Well, I usually think about the complexity of a layout kind of along two different lines, which are still kind of related. So the first of those is the number of views. So it's not hard to see that if you have a layout with hundreds and hundreds of views, it's going to take up a lot of memory, right? Because all those views have to be instantiated. But another way to think about the complexity of a layout is in its depth, right? So how many views you have nested inside other views, inside other views, inside other views, and so on. But really what we're talking about when we talk about the number of views, when we talk about the depth of the view hierarchy, you know, how much is nested, what we're really talking about is the number of times that each view has measure and layout executed. And, you know, you might write 100 apps that never have any problems with these two method calls. But at some point, if you write a really complex application with, you know, a really complex interface or an interface that's just really animated and delightful and has a lot going on, sometimes these two methods can cause you problems and basically cause you bad performance. And what happens when you have bad performance in a UI is you get jittery animations, you get jank, you get bad user experiences. So really, lean layouts matter, efficient layouts matter for your user experience. But it's not just about your users, it's about you as a developer as well. If you make concise, lean layouts, you actually increase the maintainability of your application. So, you know, I mentioned that performance resources that a view hierarchy consumes is directly proportional to complexity. Well, it's not just the resources of your application and your device, but it's your resources as a developer that get chewed up by complex layouts because you'll be up late at night without coffee, looking at this layout, wondering, how can I refactor this? How can I maintain this if it's too complex? I mean, really, it comes down to readability, right? Like, imagine an XML layout where you have like dozens and dozens of views and there's like tags everywhere. That's just hard to parse for you as a developer. And, you know, and think about if you have a layout that has like lots of children and other children. You can think about it, like if you properly format your code, you know, as you nest, that code gets like further and further and further indented, right? And soon your code's like halfway off the screen, you can't even see it anymore. Again, it makes it less readable, less maintainable. And when layouts are more complex, they become less stable. So think about a relative layout. Relative layouts are awesome. They allow you to do all those really cool constraints that say, okay, I want this view to the left of that view, on top of this view, and in the middle of this view. That's really great, but when you have a relative layout, say, that just has a lot of these constraints, that has all these dependencies, imagine just taking one view out of that relative layout. Things will just start kind of going all over the place. Things will render where you don't expect them. Complex views become more unstable. So when you can make leaner layouts, when you can make your layouts more concise, rather, you make them more stable. And again, lean layouts are not just good for your users and their experience, but they're also good for your developer experience as well. Okay, so that's why lean layouts matter. And let's talk about why layouts can cause problems. But let's first start off with kind of reviewing how we actually turn our XML layouts into something that gets drawn up on your device screen. So usually what happens is the first thing is that you have an XML layout, and at some point that gets inflated. And all of those little tags in your XML layout become actual view instantiations. So before these view instances can actually be drawn on the screen, 3 things have to happen. I'm going to talk about 2 of them. So the first thing that has to happen to this view hierarchy before it gets drawn is that it has to be measured. And then after it's measured, it needs to be laid out. So basically, we need to find out the size and position of these views on the screen. And so basically, at each step, Android goes through your view hierarchy in a depth-first traversal and just goes into a view, measures its children, goes through that children's children, and so on. And then the same thing happens with layouts. Starts at the root and then goes on to a node, to its children, to its children's children, all the way till we finish measuring and laying out all the views. So a lot of times, there's nothing wrong with that, right? You could write so many apps and never have a problem with any of these 2 phases. But sometimes you can have problems, and they can come in several places. So basically, if you start out and you have a very complex hierarchy that's really deep, has a lot of views, that's just going to naturally cause you problems because, again, the more views you have, the more memory it takes up, the more views there are to process, the more views have to go through measure and layout. And if those views are really nested, one into the other, you basically have just, you're increasing the recursion that occurs with those measure and layout passes. And again, increasing complexity, increasing the amount of times that measure and layout get called. So another place, though, that performance problems can happen is when something changes. So say you have a view hierarchy, like this one up there, and say this pink view decides to change. It changes size or position. So what happens is that now that that view has changed, it has to be remeasured and relayed out. No problem, right? Well, this view might have a sibling, and usually the position and size of your sibling is dependent on that original view. So at some point, that sibling has to be relayed out as well. But the size and position of the parent is also dependent on that view and on that sibling. So once that first view changes, its parent will also have to be measured and laid out. And if that parent has a parent and that parent has a parent, basically these invalidations, this need to remeasure and relay things out again, goes all the way back up to the root. So as you can see, the deeper this view that changed is, the more that those invalidations have to occur, the more that you have to do to redraw that view hierarchy. Now, change is good. Change is unavoidable. And, if you think about it, we live now in an Android world where we have material design, right? Where we want to make things animated and beautiful, when we care about motion design. But what is motion but animation and change? So really, this kind of problem, this kind of invalidation, chaining up the ladder all the way to the root, you can't avoid that if you want to make beautiful, interactive, expressive apps. So it's just something that is going to come up, and maybe it won't cause you problems some days, but some days it might. So another place you might find problems is within the platform layouts themselves. So relative layout, I just mentioned a little while ago, and relative layout is a great component, right? It gives you all these really cool attributes that you can position things in cool ways. The problem with relative layout is that on its own, it always requires 2 measure and layout passes. And that's because of this kind of really cool ability to do these constraints. because the relative layout will actually do two passes. The first is just to kind of measure and position each view according to what its own request is. And then it'll go back through another measure layout pass in order to satisfy all those constraints that might have been imposed on those views. So as you can see, you basically get hit with an extra measure layout pass right out the box with relative layout. Now you might say to yourself, oh, okay, well, one extra measure layout pass, that's not so bad, right? But the thing is, it's never just one more. It's double, you know? And just think for a minute if you had a relative layout inside a relative layout. That parent relative layout gets laid out twice, but that child relative layout gets laid out 4 times. So as you can see, like, these problems with layouts aren't like additive, they're actually multiplicative. You know, things multiply and chain on each other. So that's kind of when you really start to kind of run into problems very quickly, because these things just kind of like roll into each other and create bigger problems than you ever would have thought. And finally, lists. You can't get away from lists on Android, right? Like, pretty much every single like app you could think of maybe has a list. You know, Gmail, Hangouts, everything has lists in it. And you know, you might say you have a view. It's not the most efficient view, but you know, it does okay on its own. Now, what if you took that view and copied it like a dozen times, 24 times? Something that might be okay performance-wise on its own starts to kind of get janky possibly and kind of cause more problems. And I mean, basically, what's a list but you know, a layout that takes a view and copies it several times over. So again, lists are something that are a valuable, you know, part of interface design and part of like what we do as app developers, but it can cause problems depending on, you know, all those little individual list items. So there's a lot of places that you can find performance problems in layouts. And the problem, there's also another problem in that, you know, we never really see any of these 4 things by itself, right? They usually kind of conspire together and work together to make your app janky. So it's really important, you know, to kind of look at each of these little things. And problems might seem small and little on their own, but together they can result in bad performance. So that's why sometimes it's okay with layouts if you're having problems to kind of do little nitpicky micro optimizations because of the way that these problems kind of come together and, you know, make issues for you and your users. So basically, you know, we can have problems in layouts and performance. Not always, but sometimes. So what happens if you do have a problem with your layout's performance? Well, you have to find that problem. And one of the good tools to use to find problems in your layout is the hierarchy viewer. So the hierarchy viewer, there you go, is an SDK tool for visualizing your view hierarchy. And it used to be standalone, but now it's part of the device monitor, and you can launch it directly from Android Studio. And I actually wrote a sample application. Ooh, that's really, okay, sorry. So I actually wrote a sample application for this, which is rendering all funny. Okay, so I wrote, sorry about this, 1 second, live demos. Okay, so I wrote an application to kind of show you different things you can do with layout and layout performance and fixing problems. So there we go. Oh my gosh. All right, there we go. And there we go. All right, so in order to show you how hierarchy viewer works, I wrote a really, really, really bad layout. Like, I made it as awful and disgusting for everyone as I could. You're welcome. And I'm going to do a lot of things. I did a lot of things in this layout that I'm going to ask you not to do. And you know, you can see from this layout that it's actually really pretty, right? I was really hungry when I wrote it, so I found lots of beautiful pictures of food, and I put it in this layout. But you can kind of see that as I'm scrolling, it's kind of janky and a little slow, right? Now, part of that is because I have all these lovely pictures of food, but part of that is because I just made this layout so nasty and really nested. And, you know, say that I didn't tell you that I did this really crappy layout for you, and you just saw this on an app. How would you be able to figure out where the problems are? Well, you can use hierarchy viewer, and so if I start the hierarchy viewer from the monitor. So there's a tab here in the device monitor next to DDMS. You can hit the hierarchy viewer. And generally what you'll see is like the device is attached via ADB. And I'm going to have to do that. And what you do is you click on a device, and usually what will happen, if this was done right, is that you should see, okay, we'll just do the emulator then. So what you'll see generally is under each device connected via ADB, you'll see a list. And in that list will be some of the activities in your hierarchy. So let's see if I can get that to come up. And by clicking on it, you'll actually get this really cool tree visualization of your view hierarchy. Now, what you can do with this is just kind of look at it and get you can look at it and get a very high-level view of where the views are in your hierarchy and kind of where problems might be. So if you see like a lot of these like little gray squares kind of all bunched together, that basically is telling you, hey, in this part of your application, you have like a lot of views. Maybe you could reduce it. Or if you see that the tree is really, really long, then that's probably telling you, oh, my view hierarchy is a little bit, deep. There's a lot of layers to it. Maybe there's something that we can fix there. So view hierarchy is really, really good just for getting a really quick glance at where problems might be in your view hierarchy. I've given this talk a few times before, and there's actually a feature in the hierarchy viewer where it tries to kind of calculate how long measure and layout and draw take. I was told directly by Chet Haas not to use this because it actually is very inaccurate. Although Chet still says, you should use the view hierarchy, the hierarchy viewer as, kind of a nice visualization. Don't pay attention to these numbers in there, and don't pay attention to any other kind of runtime metrics. They're not accurate, but it's still a very good tool to use for measuring performance. So another little quick hint when you're using hierarchy viewer is basically just use it on a physical device running 4.1 and up. If you run it on 4.0 on a device, it either has to be unlocked or it has to be running an additional view server in order for the hierarchy viewer to work. So just go ahead and save yourself some trouble and use it on a physical device on 4.1 and up. So there's a couple other tools for measuring problems in your layouts that I'm not going to go into too much detail. There's systrace, which basically gives you a report on basically how system and application processes are executing. There's very specific information about how frames are rendering and how much time those frames are taking up. Basically, if you want a smooth app, which is, I guess people say is about 60 frames per second, that's about how fast it needs to render for it to be smooth. Those frames need to render in about 16.6 milliseconds. So if you have anything that's kind of taking longer than that, systrace will actually point it out. And again, I'm not going to go into too much detail, but I think Francois, who has the next session, is going to go into a little more detail about systrace if you're interested. So another tool that you can use is dumpsys. And dumpsys basically collects and spits out a bunch of interesting information, as the documentation says, about different system services. And there's some very specific information that you can get on how frames are rendering using the dumpsys and using the GFX info, the graphics info argument. You can get some performance information related to the animation of the frames. And if you use a kind of a new argument called frame stats, which was available since Marshmallow, you can actually get really specific timing info, like when does this layout phase start, when does that layout phase end. You get these really detailed information. So if you are really looking for that kind of level of detail, you should definitely look at dumpsys. All right, so that was finding problems. Once you found the problems, you need to fix them. So when it comes to fixing problems in layouts, it's kind of nice to always start with lint. Lint is a great tool. Sometimes it's your friend, sometimes it's your enemy, depending on how much coffee you've had that day and how grumpy you are. But lint generally complains about things that are really good ideas to start with when it comes to improving the performance of your layout. And they're usually straightforward things, and they're just honestly things that you should not be doing if Lint is complaining about it. So let's go back to my really gross layout here. So if I go ahead and open up Android Studio, and so there's there's lots of different warnings that you might get for layout problems from Lint. One of these might be that a parent is useless. So what does that mean? So basically what happens is that if you have a layout and you have, say, another layout around it, like it's the only child of another layout, and that inner child, that inner layout, doesn't have any padding, doesn't have any margins, doesn't have any background or other kind of graphical things going on, Lint will just say, hey, why is this there? It's not doing anything. And Lynn's right, you should get rid of it. There's no reason for that to be there if it doesn't have, again, positioning or graphical value to that layout. Just get rid of it, and you'll basically get rid of an entire layer of your view hierarchy and just like, a whole other view group. So again, something that Lint yells at you for, but that you really should fix, and that's good to fix. Another thing that you might see is Lint warning you about nested weights. I love weights in linear layout. Weights are really, really cool, but when you have a weight inside a linear layout and another linear layout inside that also has weights, you're going to run into that same problem again where, the weights are great and are very useful, but they basically increase the amount of effort that the linear layout needs in order to calculate the position and size of its children, right? So if you take that effort and double it by nesting the weights, you've basically, again, really dramatically kind of hit the performance of that layout. So don't do it. From my experience, whenever I've had nested weights, I've always found that there's a better way of doing the layout. So if you have a nested weight, really just don't do it. Just don't do nested weights. Think of a different way, refactor it, kind of rearrange things a little bit, use different layouts, whatever you have to do. Nested weights are bad. Listen to Lint. So another thing that Lint will yell at you for is depth. So I kind of created this really nasty linear layout that has a linear layout and a linear layout all the way down, down, down. And Lint will yell at you if you have more than some number of views. And it's actually controlled by an environment variable. I think it's called Android lint max depth. And basically, if you're at this point where Lint is yelling at you for nesting too much, you probably have a problem and you want to fix it. I mean, you can kind of see here from the screen. It's kind of silly, right? I'm basically almost off the screen with my linear layouts. So again, something that Lint complains about that you really should fix, and that is a good warning sign to you that your view hierarchy might be too deep, might be too complex. All right. So say that you made Lint happy and your hierarchy is still your views are still kind of janky and not performing well. Well, there's some other things you can do. And the next few things I'm going to talk about is basically centered around simplifying and reducing the views in your view hierarchy. So, any kind of thing you do in app development, there's usually tons of ways of doing something. And when it comes to layouts, there's a lot of different ways to lay things out. There's a lot of different ways to create a design in a layout, right? Usually, if you're having performance problems, you want to opt for the simplest way. And kind of one of those ways to simplify and reduce is just using attributes. Sometimes the views themselves have attributes and features that can help you reduce the number of views that you need just by specifying things as attributes rather than creating them as other views. So one of the kind of best ways of doing this with text views anyway is compound drawables. And so here I have, a screen in my app, and I've got an image and text. And you see that everywhere in Android, right? Image, text. Now, when I first started Android, I know that I thought to myself, oh, an image, so I'm going to do an image view, text, so I'm going to text view, and I'll just stick it in a linear layout because it's in a line. Well, there's actually a better way of doing it, and Lint will yell at you for this, and you can actually use compound drawables. Now, compound drawables are just attributes that live on the text view that allow you to specify a drawable that text view will render for you either to the top, bottom, left, or right of the text in that text view. And what happens is instead of doing the linear layout, image view, text view, you can just use a drawable inside the text view, drawable end, drawable start, top, bottom, and you can even do drawable padding to adjust the positioning of the image to the text view. And what you've done by using compound drawables instead of doing it the linear layout, image view, text view way is you've gone from 3 views, linear layout, image view, text view, down to 1. And you've reduced an entire level in your tree. And that might not seem like a lot, but again, it's all these little things, and it actually makes your code easier to read, and it's less to maintain because there's less views. Okay, so another thing that you can do in terms of reducing views, especially when it comes to text, is to use Spano Bowls. So I have some text here, right? I'm rendering this conversation between two people. And I've got person A in one font and person B in another font. And I know like when I started Android, I'd probably say to myself, oh, that's 3 text views, right? And I'll have one style for person A and one style for person B. So that basically resulted in 3 text views. But you actually don't need to use 3 text views for this. You can use Spano Bowls. Now, what Spano Bowls are this Android platform feature where you can take a string, take a subsection of that string, and apply a style directly to that subsection. So instead of going through 3 different text views, you can just take a string, style each portion that you want styled using Spano Bowls, and then just assign that to a single text view. And the code for that looks like that. Now, basically what happens is you're trading in the 3 text views and those style attributes for Java code. And it's a really great tool to use. It might not always work for you, but it is a way of reducing down the number of text views and making things simpler. You have to be careful with Spano Bowls, though, because they are in Java code, so you don't have the niceness of having everything in your XML layout. And you have to be really careful with localization, because whenever you kind of define subsections of a string to apply a Spano Bowl to, it's done by position. So again, with localization, you have to be really careful depending on what part of the text you want styled. So Spano Bowls are good, not always, may not always work for you, but again, another tool that is not more views, just another tool for you to reduce the number of views in your view hierarchy. Okay. So just kind of some other quick things, like a lot of times when you're doing layouts, you might need a divider, right? Like a single line, or you might just for some reason have to space 2 views out, kind of like in a very specific way, and you can't use padding or margin with it. So I know like I would just usually like throw, when I first started, like throw a linear layout in there, or throw an invisible button in there and to hold the space, or I throw a linear layout there, set a background, make it really short, and that would be my divider. Well, you don't have to do it. You can actually just use a plain view, or if you're trying to just get space, there's actually a space widget. Now, the benefit of using these, like using a view or using a space as opposed to just throwing in any other kind of view in there, is that the view itself doesn't have as much overhead, doesn't have as much going on as a linear layout, a relative layout, those kind of things. So you're reducing the amount of computation you need to actually process that, which is great because if you're just using it for a divider, just using it for space, you want it to be as light as possible. And another thing that kind of I know I used to do and I've seen done too is kind of basically like using kind of wrapper layouts to add space or to add backgrounds. And generally, like if sometimes you feel like you might have to like wrap something to get it positioned correctly, but sometimes you can just either consolidate, add padding and margin together. You can just set backgrounds directly on the views. Just make sure that you're not just adding a wrapper just because it might be easier to do the padding or the positioning or the styling. Sometimes it's better just to keep everything, all those attributes set on your content. Okay. So. And again, this example of that, so somewhere, like I might have like a linear layout that has all of my content, all of my views in it, and I'll decide to position it using a frame layout. But again, if I can just set those like values directly in my linear layout, I save myself, maybe like 1 or 2 levels in my layout, and I save myself a view. So, that's kind of basically using alternatives to views to reduce your layout complexity. But sometimes it just comes down to picking the right view or layout. So, and I'll show you a quick example of this in my app. Okay, so actually it's down here. So here I have 3 text views. And say that I just wanted to align 2 of them with each other vertically, and then those 2 get aligned horizontally with a 3rd view. So if you're kind of just thinking quickly how to do this, you could think, oh, okay, well, a linear layout for those 2 that are vertical to each other, and then another linear layout to take those 2 and line it horizontally to a 3rd one. You can do that, and that's fine, and it works, but there's probably someone in the back saying, oh, well, why don't you use a relative layout? Well, you can, and that's like a good use for relative layout there. And again, by using a relative layout and using those constraints rather than trying to use like too many nested views, you can actually go from something like what I have in my example, which is 5 views, 3 levels in my view hierarchy, down to 4 views and 2 levels. So again, sometimes just picking the right view, or right view group. So another thing is, I've actually seen this a lot and it drives me crazy, is sometimes I've noticed people I would work with would do a relative layout, and they'd have n views in a line, and instead of using a linear layout, they do this one above this one, and this one above that one, and that one above this one, and that one above that one. Please don't do that. Use a linear layout. And there's a couple different reasons why the linear layout is so much better than the relative layout. The double layout pass, and also by doing things so manually, you're actually adding more ID resources, right? Because each single one of those needs an ID resource to be laid out relative to the one above it. So again, kind of one of my pet peeves on simplifying and reducing things, picking the right view group. And sometimes I talked about relative layout. I actually don't like to use it as much as I can because of that double layout pass. And sometimes if you're just using relative layout to, say, align something to the top of something or align it to the bottom of a parent, you can just use frame layout and layout gravity. Now, I kind of am cautiously saying that because I know that I had a lot of problems with this on gingerbread, like layout gravity wouldn't behave like I wanted it to, but I think probably around like ice cream sandwich and up, it's kind of behaving as expected. So definitely something that you should look at rather than relative layout when you're just trying to align things relative to its parent. And finally, this actually came up. If you watched any of the videos from the Android Dev Summit, there was a talk by Chet Haas and Romain Guy called The Naughty Bits of Android. And they very specifically said, don't use relative layout in the root. And they even noted that, when you make a new activity in Android Studio, usually the XML layout that is generated has the relative layout in the root. That's bad. Don't do that. And again, the reason for that is that if that layout becomes really complex, you'll get that double hit, that 2 times the measure layout pass just automatically. So don't do it generally. So I guess my last point, though, is that all of these things I just talked about, they're not set rules, to be honest with you. They're things that you can do to improve performance, but really what's best for you and what the right layout is for you, it depends. So I had this come up a couple times, well, should I never use relative layout? Well, no. If you have a very simple screen that has like 3 views in it, you can use relative layout in the root. Just don't tell them I told you that. But if it works for you and you have no performance problems, that's fine. The things that you might, when you run into performance problems, when you get jank, when you get jitter in your interfaces, that's when you really should consider these things. And that may be when these things are right for you as opposed to something else. All right, so say that you picked all the right layouts, you made Lint happy, you reduced everything down to what you could, and you still have performance problems. Sometimes the option for you might be to do a totally custom view group. And I'm not going to go through a full example of doing view groups because they're difficult, they're complex, and they're a lot harder than just taking a relative layout and a linear layout and just putting it in your XML file. But the advantage is there's a lot of advantages to doing it. The first is that you get total control over measure and layout logic, and the second is that you get to, by having that total control, you can actually remove these double layout penalties that you get from using some of the platform layouts out of the box. And if a custom view group doesn't work for you, you can even go down and do a totally custom view where you're drawing every single little thing in that view. And I actually love doing custom views. I'm a little bit addicted to them. I probably do them more than I should, but they are difficult and they are time-consuming to do correctly. And but it could be the answer to your problems. I definitely ran into this myself where I had some list views with some really complex data that I was rendering for I think it was like a commerce app, and we had these little items in the shopping cart that had lots of data in them, and doing it kind of like a straightforward way with just views, we got a lot of jankiness in the animation when you would swipe to dismiss and things like that, and I ended up having to do a custom view. But there are other times where I just had to make it a little bit simpler. So again, custom views are great, custom view groups are great. They're not always for you, and they do require a lot of time and patience. And if you do them, start out with something simple and straightforward. If you've never done one before, start out with a simple, straightforward layout. Maybe something that's static. Static content is always great. And generally something that has very little user interaction. One of the kind of downsides to creating your own custom view, especially, is that you don't get the nice, gesture handling and other kind of niceties that you get with button or text view, and also accessibility, you have to handle on your own. So you kind of have to balance out these things with the need to improve the performance. And that's kind of also the big kind of guideline to using custom view groups, is that you have to balance the performance gains that you get from it with the amount of development effort that you put into it. So again, might be for you, might not be for you. I encourage you to go ahead and try them. but they, again, might not always be the best thing for you. So I'm going to wrap up with just talking about good practices. So generally, when you're talking about performance and layouts, again, you might write, you might not often come into like performance problems with your applications and your layouts. If your application is simple or straightforward, or you just are really good at writing layouts, you might never run into problems. But sometimes you might, and sometimes you work in big teams with lots of different people and different styles. It's really important then to kind of anticipate and develop good habits, and always like kind of think to yourself, well, I have like some really dense information that I'm showing, or maybe I have like a screen that has a lot of animation or interaction going on, and to kind of think beforehand, what do I need to do to make sure that this is performant? Because usually it's easier to, lay it out efficiently beforehand than try to go and find where the problems are. And, in general, if you're doing something complex, if you're doing something with a lot of interaction, try to use the simplest solutions where possible. Generally, what happens is when you have bad performance in layouts is that you're doing too much and basically causing a lot of stuff to go on with the measure and layout. So don't do too much stuff. And try for fewer and flatter views and view groups. And don't let problems accumulate. And that's really hard to do. We all have deadlines, we have to ship code, we all have big teams, we have to actually produce apps. But because of the nature of performance problems with layouts, because they multiply, because something little can, in the end, create a really, really big problem for your user experience, you have to every once in a while take a step back, evaluate, say, can I cut corners here? Can I kind of go less efficient? Or is this going to be something that's critical to the experience of my app, to the performance of my app? And see if there's something that you can do better. And the best solution, it depends. All of these things that I talked about are generally good things to do, but whether it works for you, whether it's worth the time, really depends on what your app is. Again, relative layout, I don't like it, but it's not always bad. And again, it depends. There's no solid solutions, and there's no solid answers. It's just what works for you and your app, and what's best for you and your users. And finally, again, balance performance gains with development effort. It's not worth for you to pull your hair out, stay up all night doing a custom view if you get just like, next to no performance gain out of it. Just always have to, do what makes sense. And that's it. And that's basically kind of my thoughts on doing lean layouts. And I'm not sure how much time I have left. I might have time for questions if anybody has any questions. Okay. Well, thank you very much for coming. And if you have any questions later, come up to me. The slides are on speaker deck, and the code that I have in my app is actually up on GitHub as well. Feel free to message me or come up to me with any questions. Thank you so much.